Hello everyone, welcome back. In this section, we're going to talk about window functions. If you're going to a data scientist interview, it's very likely that you will encounter a few SQL problems that aim to test if you can write a window function. I'm going to break down this section into 4 lectures. In the first lecture, I will teach you about some of the basic window functions, such as average, min, max, count, etc. In the second lecture, we're going to talk about row number, rank dense, and which can solve a lot of common use cases, such as generating ranking indexes for underlying groups, which you will encounter a lot at work. In the third lecture, I'll teach you how to get robust statistics, such as quartile, quintile, decile, median, using antile and percentile related functions. In the last lecture, we'll be focusing on lag and lead, which can be very helpful, especially when you're dealing with time series related data. Let's get started. Hi, in this lecture, I will show you some basic window functions. Window functions are a family of functions. It's not a specific function, but rather a special set of functions that perform a calculation across a set of table rows that are somehow related to the current row. It is comparable to the type of calculation that can be done with an aggregate function. But unlike regular aggregate functions, you can use a window function and not cause rows to become grouped into a single output row. Each single row retains their separate identities. Behind the scenes, the window function actually processes more than just the current row of the query results. In this lecture, I want to show you how to write a window function with average, min, max, and sum. Let's take a look at an example. In this first example, I want to compare each movie DVD's replacement cost to the average replacement cost of all the movies that from the same MPAA ratings. For those of you who are not based in the United States, MPAA rating is a film rating system in the United States to rate a movie's appropriateness for certain audiences based on its content. For example, capital letter G means all ages can be admitted into this movie watching, and PG-13 might contain some materials that could be inappropriate for children under 13 years old. A couple of things to notice in this SQL query. You have seen the average function before, but in this query there's no group by clause. How does the SQL engine know which rows to use to compute the average from? It's actually the partition by clause inside of the over function. The partition by rating means we're computing the average for each unique value of the same rating. And in the final output, every row has the average cost inside of the same rating. So you can also do things like replacement cost for that movie divided by the average cost, so to get relative expenses for each movie comparing to the other movies inside of the same rating. And if you wanted to try out this example by yourself, please feel free to go to SQLpad's playground and play with it yourself until you get comfortable with it. I've included the code of the queries in this lecture's documentation. Feel free to try it out yourself. Let's take a look at another example. In this example, I wanted to compare any movie's length to the maximum length of a movie that belongs to the same movie category. It's very similar to the previous example, but instead of using average, I'm combining max with over and partition to create a window function so I compute the maximum movie length inside of the same movie category. So for example, for the first movie, Storyside, its length is 163 minutes, and the maximum length of any action movie is 185 minutes. If I divide 163 to 185, I can sort of get a sense of how long this specific movie is comparing to other movies inside of the same category. Let's take a look at another example, which is the final example in this lecture. This one is actually quite complicated. In this example, I wanted to calculate a running sum of the movie length using the window function. Assuming it's holiday season and I want to binge watch all of the 1000 movies, starting from movie ID equals 1. After finish every movie, I want to find out what my overall progress is. I'm using sum and over to calculate a running total of time to get my overall progress. And this pattern could happen a lot at work, and the overall progress could be a very useful metric to have. Notice that there's no partition by clause inside of the over function, because I'm not grouping those movies into any subcategories. I simply wanted to compute my overall progress. That's why I'm not partitioned by any groups or category of those movies. And another thing to notice is that if I don't add anything inside of the over function, I'm actually getting the total number of minutes from the entire movie catalog. As you might notice that they all have the same value of 115267. But if I add the order by clause inside of the over function, I actually get the total number of minutes up to that specific row, which we call it running total. Again, if you're not super comfortable with this query and feel like this query is a bit of outlandish, feel free to go to SQL Pad's playground and use the attached code until you get very comfortable with this example. Now it's time to do some exercises. In this lecture, I've prepared 4 exercises. I'll also try to give more detailed instructions for every exercise. You might find those exercises a bit harder to solve comparing to our previous exercises, since you might be relatively new to window functions. But don't worry. If you're really stuck at a certain problem, I will show you my step-by-step solutions in the next lecture. See you in the next lecture. Alright, I hope you enjoyed those 4 exercises. If you feel like those exercises are a little bit hard to solve this time, don't worry, we will have more window functions for you to practice at the end of this section to further fine-tune your skills. Let me walk you through my solutions. Let's first take a look at exercise number 58. The goal of this exercise is to find the percentage of revenue per movie. And to do that, we will first need to calculate each movie's revenue. And we can use a payment table and rental table and inventory table to sum up the amount per movie. After that, we can use a window function to compute the total revenue of all the movies. Remember in the lecture that I showed you that if we don't add anything inside of the over function, it will aggregate over the entire table and keep the result for each row. So let's use that. One thing you might have noticed here is that I'm multiplying each movie revenue to 100.0 and not 100 to get a percentage. Why is that? This is actually a very important trick in SQL. If you don't add 0.0 at the end of 100, because we are dividing revenue to the total number of revenue, and if the revenue is not stored as a float, but rather an integer, you multiply by 100, you might not be able to get the level of accuracy you wanted. Let me show you a quick example. Let's do a simple division. Let's just do select 2 divided by 5. And because both denominator and numerator in this case are integer, the SQL engine will assume that the result will also be an integer. So if you run this query, you'll actually get 0 instead of 0.4. To solve this problem, especially when you're doing divisions, very often you multiply the numerator to 1.0 to convert the results into a float type to get the level of accuracy you are expecting. For this specific exercise, it doesn't really matter because revenue is already a float type. Let's move on to exercise number 59. This one is actually very similar to the last exercise, but instead of computing a movie's overall contribution to the entire movie catalog, we're computing its contribution relative to its movie category. So the denominator here is going to be the total revenue for the movies in the same category with this specific row. Again, let's break down the problem into two steps. In the first step, we calculate revenue for each movie, and after that, we use a common table expression to create this a nice temporary table called movie revenue. And after that, we can join this movie revenue table to film category to get the category ID. And to get the category name, we then join the results to category table to get the category name. And notice that here we are adding a partition by inside of the over function so that we can get the revenue per movie category instead of the entire movie catalog in the last exercise. Let's move on to exercise number 16. Exercise 60 is about the number of movie rentals. So instead of summing up the payment to get the total revenue per movie, we want to find out the number of times a movie is rented relative to its movie category. So we use average rentals to get the average number of rentals per movie per category. And we use partition by to compute the average number of rentals per movie category. Let's take a look at the last exercise. This one could actually be potentially very tricky if you use a switch to a different store. But for simplicity, we can assume that each customer only belongs to one store. And it's going to be very important for you to clarify this with your interviewer if you're going through an interview process. Again, for this problem, let's break it down into several steps. In the first step, we can compute the total number of revenue per customer per store. And because each customer can only belong to one store, we can use the max function to get the store ID associated with each customer. After that, we then take the average function over partition by store ID to get the average customer spend per store. We then combine this to compute the average customer spend per store together with each customer spend. And because for this exercise we only need to return 10 customer IDs, we can then use a subquery to limit our results to those 10 customers. I hope you enjoyed those 4 exercises, and if you feel those exercises a little bit challenging to solve, don't worry. We will spend more time to talk about window function in the next 3 lectures, and there will be plenty of opportunities to fine-tune your window function skills. I will see you in the next lecture. Hi, welcome to this lecture. In this lecture, we will go through some of the very important window functions, including row number and rank. Let's get started. In this first example, our goal is to create a ranking index based on the length of a movie for the entire movie catalog. As you can see, the row number generates a sequence of integers starting from 1 for each row. And you might have noticed that the movies with equal length actually have different row numbers. Those row numbers are actually randomly assigned, so their ranking is not consistent. And finally, each row has its own unique number. Let's take a look at another example. Instead of comparing movies based on the length from the entire movie catalog, we can create a row number within each movie category with the help of partition by. The row number with over and partition by is a pattern that is very often used together. It's a very powerful pattern in advanced SQL. Mastering row number with partition is going to make your data analyst job much easier. For example, imagine you are working at an e-commerce company and you have a global business. You want to find out the best sellers inside of each country. You can easily use row number to generate top 10 bestsellers for your report. Let's take a look at another function, rank. Rank is actually very similar to roll number, but there are some tiny differences between the two. The major difference between rank and roll number is that rank will assign the same unique values if there are ties, and will restart the next value with the total number of rows. So it jumped from 1 to 11 in this example. And the largest number of ranking it could get is gonna be the total number of rows. Since we have 1000 movies in here and there's no tie in the last row actually have a rank of 1000. Very similarly, we can also generate rankings inside of a partition instead of the entire movie catalog with the help of partition by. The last function I want to show you is dense rank. It is very similar to rank in terms of how it treats ties. The only difference is that it will restart the next value to be a continuous value to the current largest ranking number. As you can see here for ties, they all have a value of 1, but instead of jump from 1 to 11, the next dense rank is 2. Similarly, we can also do partition by with dense rank. The largest value for a dense rank is going to be the unique number of values for that column inside of a specific partition. In summary, roll number, rank, and dense rank are three functions that are very helpful in generate rankings, especially for a subgroup of data. I have used roll number most often at work from my own experience, and rarely use rank when there are a lot of ties. Alright, it's time for some exercises. I have prepared 3 exercises for you to reinforce your learning and practice roll number, rank, and dense rank. If you get stuck, don't worry, I will show you my step-by-step solutions in the next lecture. Good luck on those exercises and see you in the next lecture. Hi, let's take a look at those 3 exercises. I hope you have successfully finished all of them. Let's take a look at exercise number 62. For this exercise, we can break it down into several different steps to get what we wanted. In the first step, we can join film table to film category to get a film's category ID. Then we can join the category table to get the name of a specific category name. Lastly, we can use roll number to create a ranking index based on the film's length inside of a certain movie category. Because the requirement is that for each category there should be only one result, we can use roll number instead of rank. Because if there might be ties, rank will assign the same ranking index to multiple rows. In the second step, we can use a where clause to limit the results based on the index that's generated by the roll number. And if we add a where clause at the end of this query to specify roll number equals 1, you actually will get an error message. Why is that? That is because behind the scene, the where clause actually runs earlier than the roll number. So in this query, when the SQL engine starts to reference to roll num, it doesn't actually know what roll num actually is. Let me show you an example. In this query, I added a clause to limit the films to those IDs less or equal than 10. As you can see here, film ID 7, Airplane Sierra, is the shortest movie inside of the comedy category. And if we remove this where clause and replace it with where category equals comedy, let's see what the results look like. And it's very clear that there are multiple movies whose lengths are shorter than Airplane Sierra. And that is actually because the where clause runs before the roll number starts to run. Roll number didn't apply to the entire table, but only to whatever left after the where clause is applied. That's why in the where clause you cannot reference the row number because SQL engine simply does not know what the row name is. To solve this problem, we can either use a common table expression to create a temporary table for the first step, and then we can refer the row name column in a second query. After that, we can call this movie ranking table and limit the results to row name equals 1 and get the results that we wanted. Alternatively, instead of using a common table expression, we can also use a derived table and get the same results. I personally would prefer a common table expression because it is much easier to read and understand the code. Let's take a look at the next exercise, number 63. For this exercise, we will need to use dense rank because we need to return all rows if there are ties. And row number will only give you unique numbers if there are ties. So we cannot use row number. We also cannot use rank function because there might be multiple ties that have the value smaller than 5, and we might lose some records in the final results. Similarly, we can use common table expression to create a temporary table that is called cost revenue. After that, let's use dense rank function to create a ranking based on user spend in each store. Finally, we need to limit the ranking to be less or equal than 5 to get what we wanted. Let's go to the last exercise, number 64. The first step again is to calculate for each movie what this movie's total revenue is. And we can use a common table expression so we can reference this table later on. In the second step, we need to return only one result if there are ties. So again, for this exercise, we need to use row number to generate a unique ranking for each movie. And finally, we need to limit the results to row name less or equal than 2 to get the top 2 movies per category. I hope you enjoyed those 3 exercises and be able to see the patterns and the power of row number rank combined with partition by, as you will probably see a lot of them during your work as data analytics professional in the future. I'll see you in the next lecture.